Hello there once again. This time we've got a new radio which has come in for optimization. So I've said before, the radios often come out of the box. They don't work as well as they ought to. This comes with an incredible mic lead. It's certainly long. This is a TTI 660. So this is a new set which is the customers. I think they've used it for a few weeks and thought we'll have it optimized. Now, TTI. I don't know whether this is still the case, but I've had one or two snags. Just take the lid off. Does it unplug? It does unplug, that's handy. All surface mount, fiberglass board, no complaints there. But I've had a couple of sets which are 2 years old and they've come suffering from microphony. Now microphony, I thought we'd got rid of when we got rid of valves. What happens is you get ceramic capacitors drawing in moisture, and then the slightest touch of the radio and it amplifies it. You can virtually talk into the radio without a microphone. They can become so microphonic. And this is, I've tracked down, this is because they're absorbing moisture into the ceramic capacitors. Now lots of CB radios have got wax in the VCO section, I bet that made a noise, and these radios don't. So we do a modification. Now I'm not into modifications, as you know. The two customers who had got microphony, I said to them, all you can do is to live with it. That isn't not something I like to have to say. With it being surface mount devices, we can't be going round swapping a dozen capacitors. It's just not cost effective. It's probably not even possible for normal people to do. These are made in a factory by machines, and pick and place is automated. Gone are the days of leaded components. We used to have this problem with some Tate business radios back in the 1990s, and you could change the capacitors, and that was the end of the problem. So what we're doing when these come in, with the customer's approval of course, is we're spraying the appropriate area with a lacquer, in the hope that the moisture will not get to the ceramic capacitors and they won't break down. Because there's nothing worse than having a radio that's only 2 years old which is unusable because of that. Mostly the components would be this side in a little tin, and of course the models do differ. I've got the full service manual in front of me for this, and I can now run through the various things we need to do with these sets. Now this is a multi, and it's set here to UK. I've got it upside down. We'll just plonk it onto channel 20. I always make sure these sets basically work before we start taking screws out and breaking seals if they're under warranty. And this radio does work, so check that. So we're going to show you the VCOs. I don't think this really, it's not going to happen that these are going to need the VCO. It's a much wider VCO with it being capable of all the different frequencies throughout Europe. But the manual says, we'll just put the earth on there. The manual says you do it on channel 1 of the CPT band. Well, I'm doing it on channel 20 because I'm not going to make an adjustment, but I'm just going to show you. There is a test point. We'll just zoom that in. It actually says VCO test point, which is there. Coil 301 is the VCO. Now then, let's get that into count. 2.77 volts, obviously that's in lock. I'll put the radio into transmit. We're getting that as a logic high. It's going to be somewhere between 1.5 and 4.5 volts. So that's fine, that's the VCO. So this isn't a repair, it's an optimization, so I know that that doesn't need adjusting. When we've done that coating, what I do is to put a modification sticker on the case. There's the case. It's got a job number on it right now. We'll just zoom out from there. And then when this comes in for repair again, we know that it's had that coating put on it. So what I do with these, it's very rare we do modifications, what I've done is to strike through the modification 1 and I've entered it on the customer's record, so I know. Now back to the transmitter. I may as well peek these. So the first transmit one is number 701 and it's down that can. Like a lot of these surface mount sets, there's less inductors than in those older sets because a lot of them are surface mount components with a very fine tolerance. So go into transmit. And the second one. Those two are optimized. If this was a repair situation, we took that can off. There could be another one under there. It does say in the manual. I don't know how it's adjusted. It doesn't need adjusting in this situation. Now, what power have we got coming out of it? We have only got 3 watts coming out of that. So we need to turn up the power. And the power control on this, I'll use the yellow tool, is RV3, I can't read it from here, it's a very small, RV911, which is that one there. And that's gone straight up to, it's capable of about 4.3, so we'll just set that at dead on 4. Now it's slightly low on frequency, so what we'll do is adjust that with CT301. CT301 is next to the reference crystal there. It should be 2779125, it's 2779108. It's neither here nor there, but we may as well pull it up while it's in. Went a mile just then, so I'm just bringing it back down. There we are, 2779126, that's fine. And then the deviation should be 2.5. And just again look at the, I've got the manual layout here in front of me. 401, which is there. So just get that little oscillator out that we have. That's reading 2. That's now 2.5. We'll just do the whistle check. Wallow. Wallow. That's spot on. Tell you what, that mic leaves a bit rustly. Might help if I lock the plug in place. So that sets up the transmitter. Moving on to the receiver now. I'll do this on one video because it's not a repair, as I say, it's an optimization. So we've brought the power up from 2.5 watts to 4. We've set the deviation from 2 to 2.5 maximum. It's now bang on frequency, which it wasn't. It was just slightly there, but it's neither here nor there, that kind of thing. Now the first receive coil is, if I can read this small print, it's 101, which is there. So put the signal generator on, turn the volume up. Of course, it's already working beautifully anyway. I'm looking at an oscilloscope, I'm looking at a synod meter. That's fine, that's the mic on the floor. Number 2 is 103. Number 3 is 104, and these are tiny. And number 4 is 105. And that's absolutely fine. 106 is, well, sorry, 107 is the 6th one on receive. And then finally we've got the FM, oh no, we've got RX7, the 7th one is 108 there. Just gained a little bit there. So it's the first one is that one, which is 101. The second one, 102. The third one, 104. The fourth one, 105. The fifth one is printed. I don't know how you're supposed to adjust that. It's in the manual. The sixth one is 107. And the 7th one is 108. And then what we now need to do is set the detector, and the detector is 109, which is there. So what we'll now do is put a big signal on, which is what we'll do is put 100 microvolts on. I'm looking at the oscilloscope for maximum recovered audio. Tell you what, I'm struggling to move this. And there we have it. So now we'll check the sensitivity. And we'll see how the squelch works. Right, the sensitivity, that's 0.3 of a microvolt. 0.2. 0.15. And we lose it just there. That's very good sensitivity. A lot of these new sets are. So we'll now set the squelch. I'll turn the signal generator off. Set the squelch for threshold. Switch the generator back on. And it actually comes straight back in. That's a good squelch. Now we'll see how it works on full. So I've now turned the squelch to